Imagine what your life would be like without electricity. Every morning you flip the switch and your lights come on. You plug in your cell phone at night and expect it to be charged in the morning. A lot of time and effort go into the generation of electricity to power every system in your house. The task starts at a power plant. One of the most efficient power plants are those powered by nuclear energy due to its low fuel cost and zero emissions. Energy is produced by a chain reaction initiated by nuclear fission. Duke Energy operates 11 nuclear units across 6 cities in the Carolinas. Together, these facilities generate more than 10,000 megawatts at capacity. To put that into perspective, you're using about 4 watts when your cell phone is charging and 400 watts when you turn on the TV. 1 megawatt is equal to 1 million watts and can power about 750 homes. Thank you for joining us on today's activity. You will experience an example of a chain reaction that exemplifies the nuclear fission that powers nuclear power plants. Electricity began to be investigated in the 18th century by Benjamin Franklin, and it rapidly revolutionized the way we live through the research of many other scientists. Engineers working on such technology encountered the problem of creating reliable sources of energy and being able to distribute it among cities and towns. Nuclear energy was discovered in the 1930s, but its powerful nature brought many challenges. Challenges that engineers have been solving using the engineering design process. By defining the problems, brainstorming, building, and testing power plants and equipment, engineers are constantly working to make nuclear power safer and more efficient. Nuclear energy originates from the splitting of uranium atoms. You may remember learning about atoms in science class. They have a nucleus that is made up of protons and neutrons, surrounded by electrons. During fission, an atom is bombarded with a neutron, causing that atom to split and bombard other atoms. This chain reaction generates a large amount of heat. We call this an exothermic reaction. This heat is reacted with water in a closed system to generate steam. The steam works to turn turbines, which make generators work to create electricity. Electricity then gets distributed through the grid system to all of us. In this activity, we are going to create our own chain reaction as an example of what happens in nuclear fission. Take a look at these dominoes. Watch as one falls to hit another, creating a chain reaction. Now watch this box of ping pong balls that are set up on top of mousetraps. They are all still in neutral until the activating ball is thrown in. Much like a neutron bombards the nucleus of a uranium atom, this ping pong ball hits one trap and sets it off. This leads to other ping pong balls bouncing around, hitting other balls and setting off more traps. In the same way, free neutrons bounce around in the rods inside a nuclear reactor, setting off a chain reaction and releasing tons of heat. Now it's your turn. Let's define the problem. To explore nuclear fission, we want to create our own version of a chain reaction. Can you set up a chain reaction with your own materials? Maybe you have a given set of items from your teacher. Maybe you're at home and you can use a box of Legos or a set of wooden blocks. Whatever you have on hand, be creative and see what you can come up with to create a chain reaction. Take a piece of paper and start drawing, writing down your ideas about how to build your chain reaction. Pause the video and take a few minutes to brainstorm. Now it's time to create. Pause the video and work for 20 or 30 minutes on building your chain reaction. Parents or facilitators allow students to do most of the hands-on work. This is a great time to develop their fine motor skills. Now let's test it out. When you have your items set up, start the chain reaction and watch what happens. Did it work as planned? Was your chain reaction successful, or were there parts of your design that did not work? Reflect on your first trial and try a different way to create that chain reaction. Can you improve on your first design? Maybe you can change part of your plan that didn't react the way you wanted. Remember, iterating or continuing to change and improve your design is what makes engineers successful. Please take a few minutes and video your chain reaction. We want to see your example. Show us your plan and how your materials reacted to produce a chain reaction. Thank you so much for participating in the Explore Mobile Lab program. We hope you learned a little about engineering and saw some meaning in your math work. Keep exploring!